Okay, today we're looking at day 2. Whoops. That is not the correct PowerPoint. Today we're looking at day 2 of chapter 8, topic 2, adding, subtracting rational expressions. Alright, so here are the steps. We first factor the denominators to find the LCD. We multiply the denominators by the missing factors to create the common denominator. Combine the numerators, and then we factor the numerator that we end up with to see if it can cancel with any of the factors of the denominator. And at the very end, we multiply everything back together into standard form. So let's take a look at number 1 here. 4 over 5a cubed b squared plus 9c over 10ab. Now if we factor the denominator, 5a cubed b squared, that's 5 times a times a times a times b times b. The other denominator, 10ab, that's 5 times 2 times a times b. So the LCD is going to be the factors they have in common multiplied by the factors they don't have in common. So they have a 5 in common, they have an a in common, and they have a b in common. Those are the factors they have in common. The factors that they don't have in common is a 2 and 2 a's and a b. So the LCD here is going to be 10a cubed b squared. That's our LCD. 2 times 5 times a times b times a times a times b. All right, at this point, we multiply the fractions by their missing factors to create the LCD. So for instance, 5a cubed b squared, we need to turn that into 10a cubed b squared. Okay, so it's got the 5, it's got the 3 a's, it's got the 2 b's. The only factor it's missing is the 2. So we multiply that by 2. And whatever we do to the numerator or denominator, we have to do to the numerator. So this becomes 8 over 10 a cubed b squared. Now for this one, 10ab, it has the 2, it has the 5, it has an a, and it has a b. What it's missing is the last 3, a squared b. So we need to multiply that by a squared b. We also have to do that to the numerator. So that becomes 9a squared bc over 10a cubed b squared. So now that the denominators are the same, we can combine them into a single fraction and put this over the denominator, 8 plus 9a squared bc. And of course we want this in standard form, so the 9a squared bc would come first, plus 8 over 10a cubed b squared. At this point, we check to see if the numerator can be factored, because if we can factor something out and cancel it with the denominator, then that's great. But these terms, they can't be factored, they don't have a GCF, so this would be our sum for number 1. Number 2, we have x minus 1 over x squared minus x minus 6 plus 4 over 5x plus 10. Okay, so it's x minus 1 over x squared minus 6 minus, okay, so 4, 5x plus 10. All right, so first thing we want to do is factor the denominators. So I have x minus 1, x squared minus x minus 6, that factors into x minus 3 and x plus 2. Okay, and then I have 4, 5x plus 10, that factors into 5 times x plus 2. So the LCD will be what they have in common times what they don't have in common. So what they have in common is an x plus 2. What they don't have in common is the 5 and the x minus 3. So the factors of the LCD are 5, x plus 2, and x minus 3. So I need to multiply each fraction so that I can get this LCD. So on this one, it's got the x minus 3, it's got the x plus 2. The only factor that's missing is the 5. So I'll multiply the numerator and denominator by 5. For this one, it's got the 5, it's got the x plus 2. What it's missing is the x minus 3. So I'll multiply the numerator and denominator by x minus 3. Now, for the numerator, you have to actually do the multiplication. So 5 times x, that's 5x. 5 times negative 1, that's negative 5. So 5, and then we leave the denominator in factored form. Okay, we don't multiply the denominator until the very end. Whoops, this is a plus sign, sorry. Plus, and then distribute here, 4x minus 12 over the same thing. So now that the denominators are the same, we can combine the numerators. So the denominator is the same, 5, x minus 3, and x plus 2. But the numerators, so 5x minus 5 plus 4x minus 12. We'll combine the like terms, so 5x and 4x is 9x. A negative 5 and negative 12 is negative 17 over 5x minus 3 times x plus 2. Now at this point, we look at the oh boy. That is unfortunate. Just 1 second. This is where we left off, 9x minus 17 over 5x minus 3 and x plus 2. We look at the numerator and we see, can it be factored? Because if we can factor something out of the numerator and cancel it with something in the denominator, then that would be great. Unfortunately, the numerator does not factor. It doesn't have a GCF or anything like that. So now we just need to put these into standard form. Okay, the numerator is already in standard form. The denominator needs to be multiplied to go into standard form. So we only multiply 2 things at a time. Okay, don't try to multiply everything together. We only multiply 2 things at a time. So 5 times x minus 3 is 5x minus 15, and that's still being multiplied by x plus 2. And then we can multiply these two together now. So it's 9x minus 17 over 5x squared plus 10x minus 15x minus 30. Simplify by combining the like terms, 10x and negative 15x, and we get 5x squared minus 5x minus 30. And this would be the simplified sum. Okay, this is the simplified sum for number 2. Number 3, x plus 10 over 3x minus 15 minus 3x plus 15 over 6x minus 30. Okay, now I prefer to just put parentheses around the polynomials when I start so that I don't accidentally think that they are factors or anything. So I'm going to start by factoring the denominators. So 3x minus 15, I can factor out a 3 and get x minus 5. I'm going to leave the numerator as 3x plus 15. We only factor the denominators. So I can factor a 6 out of this, which means I'm factoring out 3 times 2, and I'll be left with x minus 5. So the LCD is going to be what they have in common and what they don't have in common. So they have a 3 in common, they have an x minus 5 in common. What they don't have in common is the 2. So the LCD, the factors of the LCD are 2 times 3 and x minus 5. So I'm going to have to multiply these to make the LCD. Okay, so for the first one, 3 and x minus 5, it's missing the 2. So I'll multiply that by 2. So it's 2x plus 20 over 2 times 3 times x minus 5. Minus. Now for this one, it already has the LCD, so I don't need to change it. 3x plus 15 over 2 times 3 times x minus 5. Okay, now they both have the same LCD, so I can put them over 2 times 3 times x minus 5. However, I've got 2x plus 20. This is subtraction, okay? So both of these need to be subtracted. So minus 3x and minus 15. Combine the like terms. 2x and negative 3x is negative x. 20 and negative 15, positive 5, over 2 times 3 times x minus 5. Now at this point, we ask ourselves, can the numerator be factored? And the answer is yes, we can factor out a negative 1. If we factor out a negative 1, we're left with x minus 5. And in the denominator, we have 2 times 3 times x minus 5. The reason we would want to do this is because now we can see that they have a factor in common. They both have x minus 5 as a factor, okay, being multiplied. So I can cancel out that factor. Now that they no longer have any factors in common, what I have left is my answer. So 1 over 6, negative 1 over 6. And that would be my simplified expression here for the problem I started with. And lastly, number 4, y over x plus y minus x over x minus y. Now, the denominators are already factored. X plus y and x minus y, nothing factors out of those. Those don't factor, so this is all that we got. So the LCD, the factors that they have in common, well, they don't have anything in common. The factors that they don't have in common are each other. X plus y, which is the only factor for this denominator, and x minus y, which is the only factor for this denominator. Now I look at what do I need to multiply? Well, this already has the factor x plus y. The factor that is missing is x minus y. So I also need to multiply the top by x minus y. Okay, so I distribute. So that's xy minus y squared. However, leave the denominator in factored form. Minus. Now for the second one, it already has the x minus y. What it's missing is the x plus y. So I'll multiply the top and bottom by x plus y. Distribute. So x squared plus xy over x plus y, x minus y. Okay, so now they have the same denominator, so I can put them both over the same denominator. So I've got xy minus y squared, and both of these are subtracted, so minus x squared minus xy. Combine the like terms, the xy's cancel, so I have negative x squared minus y squared over x plus y, x minus y. Now we would check to see if this factors, negative x squared minus y squared, and it does because a negative 1 factors out of it, which gives us negative 1 x squared plus y squared, and then x plus y, x minus y. But it no longer factors anymore. Okay, numerator is now fully factored, denominator is fully factored. They don't have any factors in common, so there's nothing to cancel. So now we put it back into standard form. So negative x squared minus y squared, and then I distribute here as well. So x squared minus xy plus xy minus y squared. Combine the like terms, these cancel. So my simplified expression, negative x squared minus y squared over x squared minus y squared. And that would be my simplified expression here for problem number 4. There's 5 problems for the homework. They're on page 109, 7, 8, 15, 19, and 21.